All right, guys, what's up? Um, this week we are going to be doing the week 6 worksheet on counting and combinatorics, and this is going to be 1.1. So we start out with A. The question premise is that are these sets finite, countably infinite, or uncountably infinite? If finite, what's the size of the set? And then the reminder is that a bit string is a sequence of digits where each digit corresponds to either a 1 or 0. So let's first look at A. Finite bit strings of length n. So here, right, we're told that these are finite bit strings specifically of length n. And in a finite bit string of length n, like say, let's just use like 2 as an example, right? Um, you have 2 to the n combinations of bit strings. And this shows you that it's kind of countable how many different bit strings or how many different bit string representations you have for every length n. So we can come to the conclusion that A is finite. Let's move on to B. All finite bit strings from length 1 to n. This kind of piggybacks off of what we found in A, where every single length n bit string can be, there are like 2n of those. So from 1 to n, there are a finite number, there's a finite number of bit strings for 1, finite number of bit strings for 2, like if we were to count the combinations, I guess, right? N here, 1, 2, 3, 4, 5. Another 2, 4, 8, 16, 32, so on and so forth, up until n, where that's 2 to the n. And at the end of the day, this is just a sum from 1 to n of 2 to the I. And at the end of the day, when you take the sum is still going to be a finite number. And that's the key idea here. And by seeing like this relation with 1.1b, we can come to the conclusion that all finite sets of bit strings length 1 to n are once again finite. C. All all finite bit strings. Now we're not going from length 1 to n. Now we're just doing all finite bit strings. Now here, right, we're not limiting ourselves with a size n before. So this, if we were to go all finite bit strings, we know every single bit string combination is finite, but um, this n now is like, this n is now like approaching infinity. You can think of it like that because a bit string can be arbitrarily long. And so when we have 2 to the infinity, that's just an infinite amount of bit strings. But we know that each bit string from like A and B, each bit string itself is finite. So while it is infinite, while all bit strings are infinite, we know that they are finite and that each one is countable. So C is countably infinite. On to D, all infinite bit strings. Now this one's a little bit tricky, but we can kind of do it by first we're gonna make a bijection here, but all infinite bit strings are like some string of ones or zeros, right? But we can um what we're gonna do is we're going to make a bijection of all infinite bit strings to the reals, and here's how. All these bit strings are like strings of ones and zeros, right? If we were to arbitrarily just put a 0 at the front here, now these are all like that, like 0 point something something something, and each binary string as like in binary can correspond to a number. And with that, that's pretty much a simple way that we can make a bijection of mapping all infinite bit strings to the reals. And as we know that the reals are um, uncountably infinite, we can, as we made this bijection, we can also say that all infinite bit strings are uncountably infinite. And now for E, um, E is all finite or infinite bit strings. And here we know that all finite bit strings are countably infinite, and we know all infinite bit strings are uncountably infinite. So this is like a little counting fact, but when you have what we have here, right, we can think of them as two different sets. And what we're doing here is we are going to be taking the union between um, let me write this out, finite bit strings and infinite bit strings. And in terms of each set's countability, this is then the union of a countably infinite set and an uncountably infinite set. And when we have the union between a countably infinite set and an uncountably infinite set, just a fact from counting, that set itself is going to also be uncountably infinite. And with that, we have concluded problem 1.1 on the accountability worksheet. See you guys next time.